Okay, in this video we're going to go over triangle sum theorem, which is just that all the angles add to 180, as well as dilations. So, start with this one. Since all the angles add to 180, I add these up to 180. Remember that the little parentheses don't really mean anything other than this is all the degree, right? So when I add it, I just need to add both parts. I've got 3x and 5x makes 8x. Positive 45, negative 2, positive 7. Let's add the positives first. 45 plus 7 gives me 53. Minus 2 is 51. Subtract 51 from both sides. And then divide both sides by 8. And we're done. Okay. Second problem is basically the same thing. Got to add them all up to 180 degrees, right? So 4x plus 5 plus 3x plus 14x equals 180 degrees. Because every single time it's 180 degrees, because that's how many degrees are in a triangle. Remember, this is only true for the angles, so if I asked you about the sides, it would not be true. But when I have degree marks, I'm talking about angles. Add these up. 4x plus 3x plus 14x, that's 7 plus 14 is 21. The only constant I have is 5. Plus 5. Subtract 5 from both sides. I get 175. Divide both sides by 21. I get 8.33333. And there's my answer there. So anytime I have this, I have the exact same thing. I've got one more of these problems for you. We should be getting decent at these. 5x plus 12x minus 2 plus 14x equals 180. Right, 5x here. I've got this term and the last term. Combine like terms. 12 plus 14 is 26 plus 5 is 31. Minus 2. Plus 2 on both sides because I'm crossing the equal sign. Divide both sides by 31. Don't worry on your test, there'll be better numbers than this, I think. But you should be able to do it either way because it's just decimals. Okay. What type of triangle is this? Well, it's got 3 equal sides, so that makes it equilateral. If all 3 sides are the same, then all 3 angles are the same. If all 3 angles are the same, then I could solve this way. I could say, since this one's 5x, this one is also 5x, and this one would also be 5x. That would be 15x, and if I add them all together, equals 180. 180 divided by 15 is 12. If you know that all 3 of these are the same, right, I could also do the 180 divided by 3 is 60, so 15x equals 60. X equals 12 when I divide that as well. So either or would work here, your choice. Over here, I've got the same thing, right? But this time I have 2 congruent sides, so I have an isosceles triangle. I have the angle that is not the same given to me. So I've got 2 choices of how to do this. I can either subtract that one from 180, divide that by 2 since I have 2 of these, that's going to tell me it was 50 degrees. Or I can say this is x, so this is x, so x plus 80 is 180. 2x plus 80 is equal to 180. 2x is equal to 100 because I subtracted. Divide both sides by 2, I get 50. Number 6. I've got an isosceles triangle again, right? This time I did not tell you any numbers though. So I do know that this is x, this one is 2x, this one and this one are the same, so this one must also be 2x. Now, if I add these all three together, what do I get? 180, every single triangle. 2 plus 2 plus 1 is 5x. Divided by 5, x is equal to 36. On number 7, this one and this one are the same, right? I've got isosceles triangles again. So I can do the same thing. 3x plus 3x plus 30 equals 180. 6x plus 30 equals 180. Subtract 30 from both sides. 6x equals 150. X is equal to 25. Okay, now we're on to dilations. I've got a scale factor of 3/4 here. So is that a reduction or is that an enlargement? Well, this is smaller than this. That means that when I divide it, I have a number that is less than 1, right? That means it's a reduction. And I can find this out two ways. I can either multiply by the numerator, then divide by the denominator, or I could multiply it by this decimal that you got by putting 3/4 in the calculator. I'm going to do it both ways. I'm going to do A by doing the fraction. So 3 times 4 is 12. 12 divided by 4 is 3. 6 times 3 is 18. And that's over 4, right? And then if I simplify that, I'm going to get 9/2. So I'm multiplying by the numerator, dividing by the denominator. I'm going to do the same thing for B. 3 times 3 is 9, and that's divided by 4. I actually can't reduce that anymore, so I'm going to leave it like that. 9 times 3 is 27, and that is also over 4. That also cannot be reduced. I'm fine with you leaving it as the fraction, which is what's nice about doing that method. The other method, right, is to multiply this by what that would be as a decimal. So I've got 12, and I'm going to multiply that by 0.75. I get 9. And -1 times 0.75 is -0.75. So those are your two options there. You can do either or. On number 9, you've got the same two options, but this time you've got 4/3. So 4 is bigger than 3, so this is now an enlargement, right? So I'm going to do A, the multiplying route, and then I'll do the rest the other way. 2 times 4 is 8. That'll be divided by 3. That can't reduce. 4 times 4 is 16, and that is also divided by 3. I put 4/3 in the calculator, find out what that is, and multiply that by everything else. So that times 9 is 12. Um, 1.33 times 12, right, is 16. And this is where this becomes a problem because I need the repeating decimal. So if I went back up and said answer times 12 instead, so let's do 4 divided by 3. I'm going to get a whole number. This is why it's nice to multiply by the fraction. And if you do that on the test and you've got a repeating decimal like that, you're going to get messed up and you'll have a whole number that the actual answer is. So 6 and 8, let's do it with the fraction. 6 times 4 is 24 over 3. 24 divided by 3 is 8. 8 times 4 is 32 over 3. That doesn't reduce, so I can leave it the same. Like I said, you can put it in the calculator and multiply it, but I highly recommend doing the fraction method. Number 10. Is this a dilation? So I need to check and make sure that I have the same scale factor for A, B, C. So I check my scale factor. That is my new point on top of my old. So for A, I have 6 divided by 3, so that's going to be 2. Right? 18 over 9 would be the same thing. For B, I have 8 over 4, which is also equal to 2. 16 over 8 is the same thing. For C, I have 4 over 2, which is 2. So yes, this is a dilation because all of my scale factors are the same. We're going to do the same thing on number 11. Is this a dilation? Well, let's find out. I need my new point over my old point. 15 over 9 has to be equal to 28 over 14, has to be equal to 17 over 12. If that reduces to be the same thing, it works. You can probably see right now it won't do that. Let's just put it in the calculator and find out. 15 divided by 9 is 1.6 repeating. 28 divided by 14 is 2. I don't have to do anything else because these two are already not equal, so I can already say no, not a dilation. Not. And this can be done the same way that I did number 10, right? I could set these all up, or I could write it like this. I recommend doing it this way because it looks like something else that we do. And kind of helps you keep everything in order. If I'm comparing the triangles, I'm writing a proportion, right? But that's it for dilation practice and triangle sum practice.